Alright, here's my next attempt at putting up these panels, and I started on this yesterday, sort of towards the end of the afternoon, and it was a bit late, so I didn't get very far with it, but I did get the cabling out of the panels done. So I've put a new cable, as you can see, into this 25 watt panel. Put a bit of siliconing around here because these cheap little junction boxes just really don't do the business to keep out the moisture. And with a 70 watt panel, put a new bit of cable here, not as heavy as the piece that came with it, but heavy enough for the job. Obviously there's two glands here, and the way I've configured it, I'm just going into one, so I needed to block this one off. So I simply made a blind end out of a spare piece of 10mm cable insulation and just filled it up with hot melt glue and just put it in there. That way that keeps that watertight. These are much better, keep out shit, as you probably know if you're familiar with solar. But I've decided to go with my jar method of termination again because it's cheap and nasty, you know, but if I need to disconnect, it's relatively easy to do so. As I've explained in a previous video, the Dolmio Grin video. But I've done something slightly different here. Right from the outset, I'm not just combining this 70 watt panel together with this 25 watt panel to make a 95 watt panel. Well, I kind of am, but I'm kind of not. I'm wanting them to remain as separate panels if need be, and initially they will need to be separate. So what I've done is I've done something quite cunning with the wiring. Now I use a lot of these cheap extension cords for my solar power lead-in wires. They're only $19 at the moment for a 25 meter extension cord, and you get a couple of molded plugs on the end that you may be able to use if you keep enough cord with them. So incredibly good value, and cheaper than any PV cable you can get out there, you know. And it does last in the environment. It discolors pretty quickly, but it keeps going. But bear in mind that I am running an extra low voltage system here. I'm not cabling like strings and you know, in series and getting up to 600 volts or even 100 volts, you know. I'm basically running 12 volt system and a 24 volt system. So, you know, if I was going for you know, a series string of a really high voltages, I'd probably consider upgrading the cables, but I'm actually not considering that because I feel that the way I'm doing it is actually unique and has many advantages I'm finding, and the biggest advantage being it's cheap, and it's cheap to add on too, and it's a really good way of doing it if you just want to grow your system as you can afford it, which I'm doing. So, and there's a few advantages in it too, but I don't know if this is not really the video to go into that. I'm just saying it's a cheap way of getting some decent cable. You know, these are 1mm square per conductor, so you just normally parallel them like this, and you end up with essentially a 3mm square cable. So obviously you need two for positive and negative. But that gets to the point of what I've done here. What I've actually done is this is the negative cable. No, actually this is the positive cable. I was trying to consider that carefully to get them right, but I can tell because this one here follows sensible colours. So this is the positive cable and that's the negative cable, but as you can see, what I've done is I've just paralleled up two cores here, the blue and the brown, which would of course be the phase and the neutral one if you used it for AC mains, and that's connected to the positive of the 70 watt panel, and the spare conductor, the green and yellow, the otherwise earth conductor, I've used connected to the positive of the 25 watt panel down here, you see. And the same with the negatives, they connect, the blue and the brown are connected to the negative of this one, and the green and yellow conductor is connected to the negative of the 25 watt panel, like that, see. So basically we're sharing out the millimetre squareages in a fair way, considering the wattages of the panels. But at the other end, now we have a choice of either doing this kind of thing, just, you know, and just treating this whole lot as a 95 watt panel coming down these 3 1mm cables that are just paralleled, or we can do this kind of thing. We can separate them and go, okay, well here's the you know, 70 watt panel and here's the 25, and put them to 2 different places. We can do that at both the positive and negative poles if we need to. Ironically, when I install it, I am going to common the negative poles and split the positive poles, because my system generally runs as a negative ground, which makes a lot more sense. Anyway, this has become quite a long video, so my next step now is to put the jar on there and put some lecky tape around it. I'll silicone up these ones once I get up on the roof, so they don't get to move much after that. I did these ones last night, but 12 hours isn't really fully enough for the silicone to cure, and I'm a bit concerned about this one, since I've sort of had to rough handle these wires to get them in the position I want them, so I'll probably just put a dab extra on that. The idea is you don't use so much silicone on these ones, so if you do want to disconnect, you just undo these ones and yank them out. Maybe a bit of craft knifing, but the other ones can stay in the jar for their next new connection. You see, that's the idea behind this. Right, so I'll get on with that now. Still not a great day for solar. We've got a bit of a cloud here, it's a bit bluer over here, so hopefully the cloud will keep going that way, where's my finger, that way, as the sun goes that way. you know what I'm saying. Right, testing time. Of course, I'm not going to drag these panels up onto the roof before giving them a test on the ground. And obviously, as I've done, I've actually cabled them up here, because of my configuration, of course, the way I'm doing it, the panel's going just here. The feed in to the actual solar shed is right there, so it's a lot easier in my case to do the cabling on the ground and drag the whole lot up there and then just run the cable. If it was a longer run, things may be different, like even the ones over the back I've done differently. But anyway, so sun is semi-out. It was out slightly better before, just of course, you know, probably if I'd started filming the meter instead of having a rant about the cable, you would have seen some slightly better amps on the meter. Well, this is the 25 watt panel. I was getting 0.9 amps and now I'm getting 0.6, which is pretty good considering this panel is totally, I'll point the camera at the sun, totally off axis to the sun. It's actually pointing on an angle slightly away from it, and the sun has sneaked behind sort of a wispy cloud up there, so that's more than acceptable. But I'm glad that I saw the high current earlier before I started filming. And there's the 70 watt panel, so we're getting 1.1 amps out of that. I wonder if I can angle them up a bit. Well, I don't know if you can even see that, but naturally that as you get a better angle on them, and they're still at a stupid axis to the sun, but this is the best I can do while filming and doing this. I don't really need to prove the maximum output of these panels. All I'm trying to do is prove that they work, which is my intention. So, you know, and anyone that's new to this, you know, you always test the panels on amps, just a short circuit current directly into your meter. You don't worry about volts, because especially with a monocrystalline panel, they can actually produce full voltage till it's almost dark, but just of course not many amps. And of course, if you had a cable with a high resistance, a bad join or whatever, and you measured the voltage, you'd still get the full voltage because your meter doesn't draw much current. So you really got to measure the amps. Don't do it if you expect the output from your panel or your array to be bigger than the current in the meter can handle, obviously. Okay, well, that's that for that little segment. Next thing I'm going to do is put these up. And here's a shot of the whole assembly. Cables, the termination jar. See, I've leaky taped it up there to guarantee the water tightness around that seal. The seals are pretty good, that's why I use the jars. And yeah, that's about all there is to it. Ready to go up on the shed. Figure out a way to get it up there. But I did want to say, oh, did you see the crocodile clip leads that I had on the meter in the last segment? Owen gave me those, so thanks Owen for that. They've come in really handy. I seem to eat clip leads for breakfast. They just disappear to all sorts of semi-finished projects everywhere. So let's get this up.